Hi, and welcome to this clip having a look at two separate buffer pH calculations using a couple of straightforward textbook questions so you can have a look at how the way the question is presented and described might allow you to decide which of these two scenarios you're dealing with. So the first scenario is simple mixing of a weak acid and its salt. So in this case, you've got the K value given at the top, and you've got 80 centimeters cubed of one substance and 20 centimeters cubed of another. So the two substances are weak acid and its conjugate base, or its salt. So there's no reaction occurring between weak acid and its salt, so no ice method or similar types of calculation required for working out the starting moles and the finishing moles of weak acid. So you work out the starting moles of your weak acid first of all, and the starting moles of your conjugate base, and you can simply plug those into the rearranged buffer calculation formula. So the Ka expression being rearranged so that H plus concentration is the subject. Think about what you've got already. You've got the Ka value. You've now worked out the concentration, or we've worked out the moles, and you can turn it into the concentration. Bearing in mind, of course, that we're dealing with the total number of moles. So 20 plus 80 gives you 100, so that's where that comes from. So B total is 100 centimeters cubed. So doing the same for the denominator, it's your conjugate base or salt, and simply multiply the Ka value times 0.16 over 0.10 gives you 2.784 times 10 to the minus 5, which when you plug into the pH calculation, minus log, you have 4.56, remembering, of course, 2 decimal places for your pH at all times. The next one is a partial neutralization. So a similar looking question. It tells you a buffer is made, so you don't have to worry about whether a buffer is made or not. It tells you that in the question. This time it's sodium hydroxide. And that's going to be slightly different because that's going to actually react with the weak acid. So our total volume is 150 plus 100, so 250 when the time comes a bit later on. So the reaction occurring, so we're going to use the ice method. You might have your own particular way of doing it, but the ice method just allows us to work out what the change in the number of moles of weak acid and the number of moles of conjugate base are. So remembering that 0.0375 is actually the number of moles of sodium hydroxide added. They're going to react with an equal quantity of this substance. So I'm subtracting this away from my initial moles of weak acid. That leaves me with 0.0125. At the same time, it makes the same amount of this. So we end up with 0.0375. So remembering that these are concentrations that we push into this calculation, not moles, we have to do C equals N over V, V total, like we talked about before. And as I mentioned a moment ago, it's 250 centimeters cubed in this case. So again, you can stick those numbers in, and that leaves you with 5.8 times 10 to the minus 6 moles per decimeter cubed. Plug that into the pH expression, and that gives you 5.24. Okay, hopefully this has been a useful quick look at how to discern what type of scenario you have in your question and how to apply the relevant rearranged Ka expression to work out pH. As always, thanks for listening. Until next time, see you soon.